It's time for lightning talks. Filter in, have a seat. Here's how this is going to work. We're going to form a line over on the left here. I'm not going to ask you to sign up for anything. Just get in line. If you have something to talk about, get in line, and you have 5 minutes when it's your turn to talk. I am going to go first to set the tone. Somebody set a 5-minute timer for me. You set a timer for 5 minutes. You. Tell me when to go. Neither of you are setting a timer. Okay. I'm setting a timer. Go. Okay. My name is Zach. I work at Phlox. Phlox is a developer tool, primarily. At its core, it configures shells using Nix. And so we deal a lot with figuring out how to configure those shells correctly for some definition of correctly. So what I came up with was a list of shell heuristics by which, or what I mean by that is these are guiding principles for coming up with a good shell implementation. I call these the Phlox independent shell heuristics, or FISH for short. So let's dive in. First, we're going to talk about bash. Function definition syntax. First of all, there's 2 of them. Second of all, come on. There we go. We have parentheses that you can't put anything in, which makes no sense. And so that leads me to ask the question, are these parentheses vestigial from a previous evolutionary form, or are they just purely decorative? Heuristic number 1, don't do that. If statements. Why is it backwards? Every time I read this, all I think of is fee, fi, fo, fum. And second of all, why is it backwards? Like, is bash stupid? So heuristic number 2, words go forwards, not backwards. Strings. Can anybody tell me how many arguments I'm about to pass to the function or command bar? The answer is no. Because it depends on whether there's spaces in that string, which means that if you do this, you'll get a fun and exciting new answer every time. And if it's an array of strings, that's also its own can of worms, so don't do that either. So heuristic number 3, please just be normal. Just take the string that I gave you and do normal things with it. Parameter expansion. Never let anybody tell you that Latin is a dead language when hieroglyphics are alive and well. Can anybody tell me what this actually does? Something like that. Yeah, I don't know why I asked, because it's obvious. Yes. So heuristic 4, don't look like Pearl. Fun fact, there's a paper that shows that if you run OCR on paint splatters, 93% of those generate valid Perl programs. That's not a joke. So that was bash. Let's talk about Z-shell. So it mostly has all the same sins as bash, with the addition of startup file fever. So there's 10 different files that at different points in time it will read from before setting up your shell. Also, some of these only run or are sourced for login shells, and also some of these are only sourced for interactive shells. And as you can imagine, all those combinations make life very fun. If you use Phlox and you use Z-shell, you collectively owe me and my team a vacation. Also, it's not actually tilde, it's something called z.dir, which defaults to tilde, but you can set it to wherever you want. So, heuristic number 5, 10 feels like a lot, maybe don't do that. Let's talk about TC shell. Command substitution. In bash, you have these parentheses and a $sign. On TC shell, you don't, because it has not invented parenthesis technology yet. So, heuristic number 6, join us in the 20th century where we have parentheses and electricity and modern conveniences. Let's talk about fish. The consistent syntax is really nice. So here, at the end of both of these, you have the word end. So no matter what kind of block you have, it's end. It's also not backwards, which is nice. Strings. There's no word splitting. So when you set a variable equal to some string, it doesn't get split for no reason. Yeah, also no hieroglyphics. That's nice. How many startup files? There's one. It's called config.fish. And if you absolutely must do different things for login shells or interactive shells, there are predicate functions that you can use to do that stuff, which you probably don't need to do anyway, but it's there for you. At this point, somebody's probably complaining that fish is not POSIX compliant, at which point I say, good, I don't care. That's it, I'm done. Next.
How does this work? Is it like HDMI? Oh,
Yeah, there's USB-C, there's HDMI.
I think, oh.
Doesn't matter which one you want. HDMI?
Oh, God, sure.
Cool.
Now to figure out the display settings. Oh, it prompted me. That's weird. No, it doesn't do that. Okay, it worked. Hi, I'm here to show off my old tool called Nix Search. So, who here knows the Nix Search subcommand in the unstable CLI? Huh? That's not big enough? What? Okay, is this good? How's this? Okay, cool. So Nix Search, the subcommand in the unstable CLI, has to go through every single package and does string matching. This is not usable. This is so slow. So I made a tool called Nix-Search that does it instantly. This is the output. And is that the old commit? Whatever. Instead of looping over the package manually, I have the index command, which has Flake support, and I can actually just talk over this, because all it does is take a minute, and it's funny if you go to System, Monitor, and you go to History. So right now it's going through all the Nix packages, I guess the immediate children packages, and now it's traversing through every single attribute sets in parallel, which spikes your CPU like this. It's done in about a minute though, so once it's all done, you can just keep Nix searching, and every time you update the system, you can just redo the index, which takes a minute, unlike Nix-index, which takes hours to run. I don't know why. Oh, it's already done, cool. And now you can do Firefox. And you can also search Nix Search, because it's in Nix packages. So if you want to use this right now, you can just get Nix packages, Nix Search, and run it, and it automatically indexes the packages and does the silly little searching. Yeah. It doesn't do modules. You have to use search.nixos.org for it, but package searching, it works fine. I use it all the time. It's really cool. And it lets you know if the packages are broken or unsupported or whatever. So that's kind of a nice thing. Yeah, that's all I have.
Somebody else come up here and talk. Thank you. Perfect. Hey, there we go. All right. So this is a lightning talk about how one could do something very cursed with computers. Disclaimer, it's just the screenshot from The Shining. All right, so in this talk, we will learn several things, including the hubris of man, things no one should ever do with computers, and I don't know, maybe a little bit about cryptography and OpenSSL and that sort of thing. So let's talk AES. What is AES? It's the Advanced Encryption Standard. It's a block cipher
Most of TLS data transfer on the web uses AES. This is kind of a picture of the structure. It does a bunch of complicated operations like this one. It's a substitution permutation network. So 10 rounds for the 128-bit version or 14 rounds for the 256-bit version. 128 bits and a key go in, and 128 bits go out and are encrypted. Normally you implement it with like AND, XOR, NOT, basically Boolean logic. So some of the operations that AES uses, this is called subbytes. It's just a lookup table. So this is kind of the permutation or kind of substitution part of the substitution permutation. Then here's where we XOR in the round key, and AES runs this through 10 to 14 times depending on the strength. Requirements, basically in software, it's integer arithmetic. So here's some of the OpenSSL source. In hardware, it's really fast because you can just implement it in Boolean logic. There's accelerators in almost everything. So SSD firmware has an AES accelerator, and there are all these instructions like x64 and ARM64 have dedicated instructions. So let's talk floating point now. So the floating point standard, IEEE 754, it's available in multiple flavors, really. There's half precision, full precision, and double precision. Several values are not exactly exact with floats. And you can see there's a layout of these bits. There's a sign, exponent, and fraction. Special values, there's plus and minus 0. Minus 0 will be very important shortly. Plus and minus infinity, and nan. Nan, notably, is not equal to itself. Technically, there's also a negative nan, although I don't really see anyone using negative nan. What would it take to implement AES using an inexact data format? So let's talk functional completeness. So you can implement a bunch of logic out of NAND gates. So NAND is a functionally complete set. You can compare this to floating point subtraction. So NAND, if you're subtracting minus 0 from a minus 0, you get a positive 0. And well, I mean, this starts to look a little bit like a NAND gate, but with the kind of bottom row switch here. So this is actually one that people might be familiar with. It's the imply gate. So A imply B. It's actually functionally complete if you can also build a NOT gate. Well, luckily, subtracting anything from negative 0 and floats flips the sign, so we have NOT. So we have a functionally complete set. And you guys might be a little bit horrified at where this is going. Let's talk about Verilog. So you can implement AES in Verilog, use Yosys to synthesize one of them to logic. Basically, the game plan is to get an AES implementation into a form we can play with in Clang. Synthesize Verilog, God's help us, has the same operator precedence as C. And basically, we can operator overload, use Clang to optimize it a little, implement an OpenSSL engine to benchmark it, and go a little bit insane in the process. It's going to be slow, so here's what the code looks like. It's a bunch of wires. Basically, we convert it to C through register renaming. So we basically parse out the assignments, change to bit slice logic, write a class that inlines a bunch of operators using entirely floating point operations through operator overloading. Compile it into an OpenSSL engine. This is actually about 4 megabytes of AVX instructions. That's mostly subtraction. Few XOR instructions that are equivalent to the negation. It doesn't actually have a floating point negation. But let's benchmark it. So here's what OpenSSL speed looks like running our custom engine. It's impressively 436 kilobits, or rather kilobytes per second for AES. But then you compare it to AES NI, and it's more like 1.6 gigabits per second, or gigabytes per second rather. It's more helpful to just look at the kind of relative speeds here. So we actually managed to implement something that was 4,000 times slower than AES NI. Further optimization. So if you actually compile this with fastmath, it actually produces a 175x speedup at the minor cost of correctness. The entire encrypted file gets filled with null bytes because LLVM, in its infinite wisdom, because I can't really blame it honestly, deleted literally all the code and created probably the world's most elaborate NOP. And the rest of the slide deck is somehow gone. Any questions? Yes, it is constant time. Yes, I have. Yeah, this was inspired by this blog post someone wrote about subtraction being functionally complete. Turns out you can just use that and compile Verilog and implement anything. So, yeah, that's my talk.
HDMI? No? Not HDMI.
Will it do USB-C instead?
Probably.
So we have USB-C. That's this would work. We have USB-C here. So we can try that.
Cool. Doesn't look like it's working.
If only we had screen sharing technology in Linux. I don't know. Is it working or not? Okay. You. What? Oh, you'll be fine. Cause go to. Yeah, go ahead. Okay. No, you do it. You do your stuff.
That is not meant to mirror. Hang on. I'm not really prepared for this. I'm trying to figure out how to mirror displays. Because that's probably like stuff all being, you know.
Yeah, so you'll go to displays.
Okay, there we go.
And you'll say this guy is, if you want to mirror.
Mirror, yeah. Because otherwise I can't see. Okay, cool. Sorry about the difficulty. So this is completely unprepared. This is on the fly. Also, it's using the local Wi-Fi, whose speed varies wildly, I guess, depending on whether or not you all are downloading Nix packages. So, if hopefully it works. Sorry? Bigger? Okay. How's this? Yes. Okay. How's this for size? Is the text on the left readable? More. I guess. Okay. Okay, cool. So I work at Rock, and we do like chip design for sort of AI accelerator chips. But as a sort of accidental thing, we started wanting to compile lots of Haskell, and not using like stack was having trouble. So a Nix guy got in there, and so we came up with our own build system, which is something like if a Nix guy decided to replace stack and then it got taken over by somebody who'd never seen Nix but had used Bazel at Google. And so, so it winds up looking like sort of Bazel in Nix syntax. It's sort of a UI around Nix instantiate that's written in Haskell, and with instead of standard env, there's a whole like a Python kind of build steps backend. With a surface syntax that winds up looking like Bazel or Blaze, if you've seen that. So, you know, if you say, I want to say, I'm going to define Haskell executable called break, and here's its main file, and here's extra flags, here's private modules, and then dependencies are going to look like this. So this is sort of like a path-oriented thing. So :lib means as well there's going to be a lib in the same file, which is a Haskell library, which has got these things. So, you know, these dependencies will all get linked in. And then we have package dependencies as well. And then runtime dependencies are going to go into the path. And then because it has to come, because I was at Google and we had this stuff, there has to be a visibility thing that not many people like very much. know, the Nix guy. He likes Nix. I mean, the more serious answer, I guess, is because Bazel doesn't, so at the time Bazel had no distributed builds. Maybe it does now. Also at the time and still, like Bazel doesn't do your toolchain for you. It's just like, well, where are you gonna get your toolchain? Well, you could use Nix. And I think the Nix guy just said, let's just stick with the Nix all the way through. It is sort of perverse, I guess, but we've gotten a lot of mileage out of it. So, you know, so here's what happens. So, okay, so then the other thing that this originally used, here, let's just see what's going on. It's a distributed build system, right? So it's also way too big for this. So, in fact, it's very idle. Okay, well, this is not a good example. There might be thousands. So, you know, on a normal busy day when people are doing stuff, there will be thousands. Like there are 122 of these builders, and these are all, well, they're all omitted because nobody's doing anything. But there are a couple hundred VMs of different sizes, which might be running thousands of jobs simultaneously. They're sort of divided up by size. You can declare your resources. You can say, I take lots of disk and lots of RAM, and it will allocate you, you know, accordingly. Yeah, so I was going to show what happens. So my coworker assured me that this would actually work. This is sort of the equivalent of changing standard env. This is like our standard env. So if I compile this thing and I say, okay, I want to build the assembler, lots of stuff should recompile. And so this is, you know, the instantiate part. This is, yeah, it's doing build, okay, not that much. The instantiate part is Nix instantiate, but after that, it's all a custom backend which replaces the Nix remote build protocol. So you can see each of these lines is a derivation. This is download time, run time, like build time, upload time. This is the machine on which it ran. This is a task ID. You can come over here and you can say, how did this guy go? You can say, look at the log, and it's like lots of junk. You can also, for any of these ones that are still running, I mean, they're going to be too fast to get them. But, you know, I can tail the log in real time in case I wonder what's going on. I can do a dry run, and I can say, well, if you built this, like how much based on previous runs, like how much do you think it would take? And how long is take the longest graph and the width of the graph and do all that analysis stuff. So, yeah, I guess. That's all custom Nix library. Yeah, we have quite a large custom Nix library. So like I said, we use Nix packages for the bottom level. That's where all the third-party stuff comes in. And it is also very complicated. But then on top of that, there's a large Nix library. And like Haskell.library is just a Nix function. And it's going to come up with not just like either one derivation, or for C++, we actually do per file. So it's going to possibly have thousands of derivations come out of that. Yeah, so it's sort of like, really is like, you know, Nix packages plus Bazel all in Nix. Yeah, so currently it does lots of crazy stuff that Bazel will never do, such as we have racks full of custom processors. So first of all, we have custom processors, custom hardware. It's super flaky. There's lots of stuff about very non-deterministic things going on. And then also we have a whole other scheduling layer where you have racks of, okay, I'm getting a 0 here. Anyway, the short version is complicated scheduling that is all hard-coded and built in. And because we built our own, we can do that stuff. For Bazel, I don't know.
see a mouse. Yeah, I guess. I just created the slides, so they're a bit messed up. Um, yeah, maybe, or maybe it's actually fine, I guess. So, yeah, I want to talk about some very common foot guns for Nix that you might run into, and some very uncommon ones as well. Just a couple ones. So we have like we have the state version, then something what I call programs.nix, and then there's another one which is like the release. Maybe some of you can already guess what I'm hinting at. So let's start with the state version. Oh, no. Let's start with the release. So, so yeah, the release tag is or used to be 24.5. So the same as basically you would think the channel would be called. So yeah, does anybody know why that might be a bad thing if you use flakes? Oh yeah, the problem is the code here is down there in the input. Can anybody see that? If not, okay, let's type it out. So it's basically Nix packet. Nix packages URL equals, let's say, GitHub NixOS / Nix packages 24.05. Yeah, is that about what you would expect, kind of? Oh yeah. Who can find like a problem in this syntax here? Or not in the syntax, but in actually in the 24.05. Why is that bad? Exactly. So I repeat for everybody. If anybody has this in their Flake inputs, their Flake and the system will never update, because this is pinned to release tag of the branch of, and not to the channel. This doesn't mean that a specific release channel of 24.5 or something like this is actually tracked. So yeah, this is, and if you look at GitHub search, there are quite a lot of people who actually have this in their input. So this is why now, yeah, the release wiki guide now recommends setting it to release dash something, so that people are aware that this is not actually like the channel. So if you see this in the wild, please notify people that their systems might never be updated. The tag doesn't exist anymore? Oh, okay, that's pretty good too. So, okay, the text doesn't exist anymore now anyway, so less possibility for foot guns for people in the future, which is really good. Yeah, then we have the state version. Does anybody see a problem with what you see here? Do you see the comment? Have you read the comment? All right, so yeah, basically the state version is there to handle the state of databases or something like that, which most of you people here probably know. But if you do this, then you never pin anything to an actual state version, because you're always on the rolling release, right, to the next release. And this could break databases. This is now also not possible anymore, luckily, because in this PR, or like this PR, like links to a couple other PRs, so parts of the state versions are now type checked. So NixOS unstable is not a valid state version, if I remember correctly anymore. So this is also quite nice. So those are two very common foot guns. But like in our hackerspace, somebody came to me a while ago, like a year ago, I think, and he asked me, "Oh yeah, can you debug this?" And I'm like, "Sure, I can try." And then I looked at the system, and the system was so weird. Like the Nix commands returned like the weirdest errors ever, and I couldn't figure out why, because I made so many assumptions. Like I assumed like the system was at least partially functional, and I tried to recover from like from like Symlinks and whatever, and I was like exploring the system. But there was something said what I did not expect. Can anybody read that? Yes, that actually happened, and this led to a very, very broken state. And yes, yes. And the switch to like it went through, right? So the Nix's system actually switched to a system that had Nix set to Git. The person probably tried to use the unstable or the Git version of Nix, but yeah, that was all right. Thank you. So there's no fix for that yet, but maybe we can find a fix for that. Yeah.
So I'm coming up as an impromptu. Was part of a conversation earlier this morning with a few people. During the first part of the Nix was whoever has the bike has the power. I'll come to bite you a little bit. Nothing too major. However, I guess as we're all here at a tech conference, it's easy to get wrapped up in technology as a whole and what that means and how much we're all involved and immersed into it. I mean, how many people right now have their heads still half deep in the laptop? So I guess more as a challenge or as a reminder, I mean, even here in Pasadena, there's so much art and beauty to be seen, you know, reminding to keep our humanity and taking 5 minutes just to appreciate something that's not tech, but could have been inspired by the tech around us. So I guess I'll end that as a challenge, just as a...
Oh, it's showing up. What? Oh, did it show up? There we go. Cool. Alrighty, so I want to do a quick demo. So one problem that NixOS solves is reproducing your systems, where if you were using some other distro and then you make a lot of changes, install programs, 10 years later you need to make a new machine, and it's like, what did I set up? With NixOS you make most things declarative, but you can still have some issues. So by default, if I make a directory, like let's say I have some weird program, it goes into my, one second. Okay, yeah, let me. Alrighty, so I have my home directory. Let's say I have some really weird program. It makes a folder in my home directory. And I guess, cool. It needs this file, right? So this file is still going to exist when I reboot on a normal system. The problem is, this could be some weird file on my system where the system won't boot if it exists. Maybe it's the same thing in previous generations. So by putting a file in the wrong place, there's a possibility you could break your system. And not only that, maybe the program only works if this file exists. Maybe 10 years later, I switch my machine. I have the same program set up my NixOS, but the file doesn't exist, so the program doesn't run. So you can see this file, this folder exists. And I'm going to reboot. Hopefully that survives the reboot. Actually, yes. Yes.
Hello? Hello? Nice.
My screen is too high of a resolution, and so it doesn't like mirroring directly.
Okay. This goes over your head.
Okay.
Like that. Yeah, it moves over your ears.
Does that work?
Yeah, let's do still. Don't mind me. I'm just touching you.
All right. Well, I can't do screen mirroring, so I'm just going to work like this. Recreational receipt printing. I bought a receipt printer. It is the best $50 eBay purchase I have ever made. I own a receipt printer. It's an Epson TM M30 and 2NT. Normally these retail for like $300. I didn't want to pay $300. My friend got me into this. So why do I own a receipt printer? My friend bought one. I am prone to jumping off of receipt printer shaped cliffs. And I made like $50 for a week of TA work. I mean, that's perfectly fine. But what about drivers? Epson is cool. They make Linux drivers. Not for Nix, obviously. Why would they ever do that? So I just go into the Debian drivers and steal the PPD file and give it to cups. That's good enough for me. But how do I print with it? There are many ways. You can literally just feed it files with cups. I am regularly feeding just images to it, and cups will print it just fine. But also, if I want to print custom things, there's the Python ESC POS library. Using that, a little bit painful. So how do I print with it nicely? I made a nice wrapper library. It's, along with all my other receipt printer shenanigans, is in that nice repository. It really is quite easy with such a wrapper. It will load up cups, it will send up everything, and it will send it with all nice styles. And in fact, if well, I'll do it later. It's not only fun, but practical. Every morning, I do legitimately have it grabbed from my calendar and print a nice receipt with everything I need to do for that day. Everything scheduled, all the to-dos, and everything. Hey guys, I'm going to the Nix store. Do you want anything? Trick question, you're getting my laptop closure. This took 7 minutes to print and about 30 minutes to roll up. It is roughly 6,000 lines. That was fun. It is the only Fetty post I've ever written that has gone anywhere close to viral. I am Lilith, aka Infinidoge, and just for fun, just because. Anyone have any favorite package in Nix packages? Rip grep. Okay. Rip grep I can do. Very small closure. Printer paper, it is about $1 per giant roll. Sure, like literally, if any of you want any of these, I've got lots of receipt paper. You can ask me. Anyone else want anything? What? Repeat that? Oh. AST, how do you, what's the actual next package? It's not a valid package. Oh. Dash grep. Yeah. Hold on. This is not a very complicated script. It is literally just shelling out to Nix path info, and if Nix path info doesn't have anything to read, it will literally just give you nothing. Yeah. Yep. There it is. Yep. AST grep. Hello. Oh, right, I don't have, yeah. This prints out really fast for the record. So, you know, here's hello. You can have that if you want. Have hello. You said Plasma 6? Unfortunately, I think the Wi-Fi will give me a fit if I try to download that. Does anything have a decent, actually, you know what? What? Firefox. That I can do. You're getting Firefox Dev Edition. I don't, well, I can give you ungoogled Chromium. Someone said ungoogled Chromium. Well, okay. Someone said ungoogled Chromium. Oh, it jammed. Thankfully, it's pretty reasonable to unjam. Oh, that is a bad jam. Okay. Let's try that one more time. I mean, yeah, like if you. Yeah. Alternatively, Micro Center buying a new PC. Chromium is marginally bigger, but only by that much. I imagine my time's up.
Yeah, but we can keep going.
Fair enough. What? Could you repeat that? Oh, W3M. I'll need. Let's see if I need to download that, because that might.
It's going to be real small.
Okay. Yeah, that is very small.
Much more reasonable.
What? Oh, LYNX. I think I have that installed, actually. Even smaller. Anyone else? Cups. I definitely got that installed. Yeah. Yeah. Which, by the way, if anyone wants any receipt printed like this, I'll be around, and I've got plenty of receipt paper. I made sure to bring an entire spare roll just in case. It's like $1 per giant roll. Like, I will. $50 purchase I've ever made.
Things I didn't think I would need to know. How to mirror my display, because I haven't done that in years. Thank you.
Yeah, so you'll go to this one.
Thank you.
Here you go.
Woohoo! All right. So I tell people sometimes that I manage my Mac with Nix, and they look at me funny, and so I thought I would share some of the things you can do with that. So surprisingly, not only can you use Nix packages, but you can also manage things from Homebrew, including all the taps, the different brews, so the regular source-built packages, or the cast, aka all the GUI apps. You can also grab and manage all the stuff from the Mac App Store, all nice through Awake and Nix, and your Terraform versions, and of course all the stuff from Home Manager and secrets like your environment file. But why in the world do you want to grab stuff like Homebrew Cast? Well, because Nix GUI apps don't work worth a crap on Mac OS, because it shoves them off in some alternate location, and that breaks stuff. On Nix OS, aside from all the stuff that everybody knows about, I manage Flatpaks, of course more packages, and I do love Disco for drive partitioning, especially on servers. And I had all this stuff in a flake, and it got unwieldy and crazy, and I couldn't reason about it. And then I found out you could break out parts of it and chunk them in a lib folder and just pull them right back in, instead of having this giant let block that's about 3 strings long right there in the flake itself. And so between my Mac and multiple Linux laptops and some servers, I take advantage of Disco, Home Manager, Nix Darwin, Nix Flatpak, Nix Homebrew, Nix Hardware, Nix Packages Terraform. Simple NixOS mail server is pretty awesome if you need to make email on Nix work and you don't want to have to figure out how to manually configure all the crap to make it work and actually do all the right things and be secure. And though it does have some rough edges, SOPS is really nice for managing secrets so that you can just store everything right in your repo. If anybody wants to see the crazy stuff I do, it's all right there.